Hello, and welcome to our presentation of the Identification and Virus Prevention Door Lock System, or IVP for short. Our team name is Potential Deference.
Going over the team members section, we have Zachary Lopez, the project head, Vincent Thorne, the documentation lead, both of whom were a part of the hardware team, and Brian Martinez, the design lead, who is a part of the software team.
The global pandemic caused by the coronavirus has significantly impacted our lives in many ways. The shocking impact caused by the rapid rise in cases is undeniable. Basic and essential daily tasks are now performed more cautiously in an attempt to prevent further cases. The majority of companies and businesses now require their employees and maybe even their customers to always check their temperature before entering the premises or facility. It is now very common for businesses and companies to perform individual manual temperature checks with a handheld thermometer. This can be an inconvenience since it requires someone to constantly be standing at the entrance.
For the product idea, we have a system that adds a temperature sensor to existing door lock systems found in many businesses. Producing too high or low of a body temperature would in turn invalidate a reading and not allow the user to enter through the door, either marking the user as potentially running a fever or a misread of temperature. Since many places already have ID systems in place, the addition of checking body temperature would create a sort of two-step verification process to enter an area and would create a more safe and secure space for the users of this product. Some of the stakeholders may include, but are not limited to, business owners, professional employees, and lab technicians.
The hardware of the IVP system consists of two major sections. First, the main console, where the user will be scanning their card and taking their temperature, and second, the locking stage, or push bar, that will be controlling the door lock. As you can see, the main console contains a Raspberry Pi microcontroller that acts as the data processing for the RFID and infrared thermometer. Upon receiving an input, the Raspberry Pi will let the user know what to do next via the LCD display. Additionally, the Raspberry Pi serves as a means for communication amongst the two major sections, telling the locking stage when it should unlock the door. Selecting the right microcontroller was essential for our design. We needed I2C to process the signal coming from the temperature sensor, and SPI, or Serial Peripheral Interface, to interface with the RFID. After the wiring was all finished, we used approximately 11 GPIO pins. Alternatively, the locking stage is quite simple. First, a relay receives a signal from the Raspberry Pi, acting as a switch for the solenoid to turn on. The push button also acts as a switch, but instead of triggered by the Raspberry Pi, it's triggered by a push on the push bar.
For our system's software, we used Raspberry Pi OS. We imported predefined libraries for each of the major components. We first tested each component individually, and we then integrated their codes into a single Python script. Finally, we developed an algorithm that will give the user enough time to check his or her temperature and will grant the user entrance based on its value. If the user's temperature is within normal range, a signal will be sent to the relay to unlock the door.
This is a quick little video montage of all the steps it took to get the design from the team's head to be actually realized with physical components. As you can see, one of the first steps was purchasing the parts based on our specifications and 3D modeling the casing that we pictured. Upon learning it would take more than a week to get our parts 3D printed, we decided to go to UTSA Downtown Wood Shop to realize the hardware design. An added advantage of wood is that mounting the devices was pretty straightforward when compared to printing plastics. However, using wood was quite challenging since one mistake could be catastrophic, and we had never used various parts like springs before in our design. This is what the casing looked like when it was finished, and this is the first test of the push bar / touch sensor combination. After confirming that it worked, the team moved on to mounting the remaining hardware to the base of the bar, drastically transforming the front of the design. This is what the product looked like when completely wired, and this is the first test of the relay. This is the team's finalized working prototype, and here's an example of its full functionality. First, the user takes their ID card, scans it against the RFID reader, and upon getting a successful result, will take their temperature, making sure to hold the temperature sensor about a centimeter away from their forehead. As you can see, it worked, so the latch retracted into the device, and after 10 seconds the latch will extend again, locking them out. Here's what happens when a high temperature is read. We used a glass of hot water as a test object, and as you can see, the device warns them that they have a high temperature and restarts operation. Here are the results for the high temperature test.
Moving on to conclusions. So here are some of the problems that we had faced. Not having the right tools available, unfamiliarity with using a Raspberry Pi and Python, online meetings, though created more flexibility, produced a foreign experience for some of us. Shipping issues. Some of the parts had been wrong and shipping may have been delayed. And lastly, the deadlines had stopped some of us from our long-term goals. Essentially, most of the issues had been derived from not having enough time in the end. Though we were all very self-disciplined, many of these problems had been out of our control. And now for the overview of the project. Overall, the team is very proud of the prototype achieving 100% functionality despite all the problems that we ran into during development and overcoming them. Seeing the design go from ideas on paper to an actual physical device while being challenged was really fascinating. This had produced a really gratifying experience for all of us, and in turn was a great learning experience.
Thank you for attending our presentation on the IVP Door Lock System. We hope you enjoyed, and if you have any questions, you may ask them now.